So in this part, we're going to work a bit more on the knight. First, we're going to set up some animations, including the walk animation and attack animation. We'll create a detection zone script, which will allow us to find the player. And if the player is within our sword swing zone, then we're going to switch to the attack state and start swinging the sword at the player. So this is going to mean that we're going to set up an enemy hitbox for a zone where we can hit the player. The knight will also need its own hit animation and death animation, which will come into play later when our knight has a damageable component, and so we'll be setting up the animator controller in general. So let's start by working on the animations for the knight. I'm going to go to the animation window. Let's create a new animation for the knight. I will call this, we'll go into characters, enemies, knight enemy. So I might call this animation knight_idle for the first one, changing the samples to 10. Let's go into art, free knight, color 1, no outline, PNG sheets. And let's grab the 10 frames for the idle animation. And let's just put them in there. And so when we hit play, we can see our subtle idle animation. Because the knight is always going to be walking, we may not see this animation very much. So the next animation we're going to create is going to be knight run. There's no walk animation inside of the knight package, so we'll just use the run animation instead. So just like with the idle animations, we're going to have to split up the sprite sheet and set the pivot offset. So let's go to the inspector, and first I want to check what it was on idle again. So let's click on one of these frames, and we can see we had the pivot set to 0.47 and 0.23. So I'm just going to use those same numbers when we create our run. So let's click on run, change it to mode multiple on the sprite mode, sprite editor, apply, and let's slice this up. Looks like 10 frames, so I'm going to do slice, grid by cell count, 10. And then we can see our 10 frames are sliced evenly, what we want. Let's go to custom pivot and do 0.47 and then 0.23. And if we hit slice, we should see our pivot is positioned nicely on the middle of the knight rather than the middle of the sprite frame. So let's hit apply. And now we can take those 10 frames and bring them into our knight run animation. Before we do that, I'm going to change samples to 10. And now let's take the 10 frames of animation and drag them in there and hit play to test it. So there's our run animation. Looking good. Okay, next we need knight attack. So create clip, knight_attack, and do the exact same steps. So up here at the top, we have attack 1. I'm going to go to sprite mode in the inspector, multiple, sprite editor, apply. We have 4 frames. So let's do a slice. It's already in grid by cell count. We just need to change the columns to 4. And the setting for the pivot is set to 0.47, 0.23, so we can slice it. And that should work well for us. So let's hit apply. And we can actually leave this window open for a second because we're going to need to do it for the death and hit animations as well. So click on hit. And this is actually a single frame, so we don't need to put it in sprite mode multiple. But let's take the pivot and set it to custom, 0.47, 0.23, positioned nicely there in the center. Hit apply. Let's find the death animation. And then we do need to make this sprite mode multiple. So change that. Sprite editor, apply. Let's slice the sheet. So it looks like we have 10 frames. So put 10 in, double check to make sure it looks good. And we still have the custom pivot settings, 0.47 and 0.23. So slice, check the pivot. Should be kind of centered on where the knight starts, at least at the beginning of its animation. You can see it's pretty good right there. And we can hit apply. So now we can take these sliced sprite sheets and add them to the actual animations. So samples 10 for knight attack. Let's get all of the frames, all 4 of them, put them in here. Okay, now let's create a new clip. So we'll have knight_hit. Let's get the hit frame, pop it in there. Samples, I'll set to 10 just to be consistent. Let's create a new clip, knight_death.anim. So death animation, 10 frames, bring them all in, and then change the samples to 10. And you can always hit play to test the animations, make sure they look good. So the death animation is not going to loop. The attack animation is not going to loop as well. So we need to grab those animations from the characters folder. Let's go to characters, enemies, knight enemy. Take the attack animation, go to the inspector, turn off looping, go to death, turn off looping. And the hit, I think we don't want that to loop as well. Idle and run will loop because those will go for an indefinite period of time. Now let's go to the animator for the night, and we can see all the animation clips have been added in here. So first off, we're going to want to change the entry point to walk. So if I click on entry and do set state machine default state walk, I'm going to just remove the idle animation from the sheet. Although it technically exists there, although the animation is created, we don't actually need it. Attack is going to stay out here, hit will stay out here, and death will stay out here as well. But for walk and run, I'm going to want to bring these into their own internal state. And actually night run is nothing there. We don't have an animation for that. So what we really want is night run as our base animation. So for now, because the night is relatively simplistic, we're just going to have 4 states here. And I won't use any sub-state machines. So we just need to set up the conditions for when each of these things happen. So although we only have 4 animations here, we could still create a sub-state machine in order to kind of prepare for more things we might add in the future. For instance, the knight does technically have a second attack, so having an attack sub-state machine might be handy in the long run. So we can right-click on the graph, create a sub-state machine, and I will rename this attack. And then we can take the night attack, copy it, and go into the attack state machine, paste it in, and then we'll edit it from inside of there. So now I will remove attack from the main state machine graph. Likewise, we could take run and create a state machine for it. So I might call this the move state machine. For instance, if the knight was ever allowed to jump or climb walls or anything like that, then having those types of things in a move state machine might make some sense. So I'm going to copy the night run. I'm going to paste it into the state machine and remove it from the main graph. So before I do that, I need to set the move as the default state machine. So target night run inside of the move state machine. For night hit and night death, I'm going to leave these things separate because I don't anticipate there ever being 2 hit or death animations, at least for this character. So I'll leave those outside of here instead. So the next thing we need to do is to make a condition where we go from move to attack. And that's going to be different for an enemy than it would be for a player because our enemy isn't going to be pressing buttons down. So it needs to know when to attack. And that is going to be when the player falls inside of its detection zone. So in advance of creating that detection zone script, let's add a Boolean variable. I'm going to call it hasTarget. So we can make the transition from move to attack, state machine attack, when hasTarget is true. So in the conditions, hasTarget is true. And then from attack to move, we can make the transition back to the state machine move directly when hasTarget is false. So hasTarget is going to be false. Inside of attack, let's also make a transition out of here. So transition attack goes to exit, and there won't be a condition for that. It'll just be exit time 1 and transition duration 0. So when the attack is done, at least for now, we can just automatically exit the attack state. And inside of move, we want to make a transition to the exit. So I'm going to right click on night run, make a transition to the exit. And the condition for that is going to be hasTarget is true. So that's how we leave the state machine. And then the substate machine will transition into attack when hasTarget is true. So we kind of go up 2 levels to enter into the attack substate machine. And this is not going to have an exit time. And the transition duration is 0. So that's for night run to the exit. So now I want to take this hasTarget string and add it to our animation strings. So I'm going to open that up. Internal static string hasTarget equals hasTarget. Also going to move the night into our scripts folder. Okay. And now we need our detection zone in order to set hasTarget is true on the animator. So let's go to the prefab for our night, open it up. I'm going to right click on it and create an empty as a child. So I'm going to add a collider. So you can type in collider and find any kind of collider 2D that you want. A really simple way to do this would just be to use a box collider, which is a rectangle, of course. So we can see our box collider right there. I'm going to offset this child's transform off to the right. So if we put this, let's say 1.5 units to the right, when it's facing the right, it'll be right here. But when the scale on the night gets reversed because we're facing the opposite direction, it'll appear over here at negative 1.5, since the scale will also apply to these position changes. So when it's facing the right, we look to the right. When we face the left, we look to the left automatically. Now let's also make this box collider bigger because that's not a very big detection radius. So I'm going to hit edit and let's expand it. So I'll bring it all the way down here over to the right and maybe we say that the field of vision, so to speak, of the knight can go right up to about here where his helmet's at. Can also make it a little bit higher. But maybe we could argue that above that, it would be hard for the knight to see since he's wearing a helmet. So I think this would be a pretty good shape for our detection zone. Now, really important, take is trigger and turn that on. This is not being used for collisions. This is only for detection. Also, I want to take the layer and I'm going to change it to enemy hitbox. So this enemy hitbox layer is going to be used for detecting or colliding with players specifically. Let's go up to Edit, Project Settings, Physics 2D, and turn everything off for the enemy hitbox, aside from the player. So I'm going to turn off enemy, player hitbox, ground UI, water, ignore raycast, transparent FX, and default. So the only thing an enemy hitbox can detect or collide with is a player. So hit X there, and that's going to help filter out the objects inside of here for our detection zone. Lastly, we need to create a detection zone script, of course. So add component, and I'm just going to call it detection zone, new script, create an add, and let's open it for editing. So our detection zone is going to need to get reference to our Collider 2D. So this could be a different type of collider than a box collider. And we don't really need to worry about corner case collisions. We're just detecting if something's inside of the collider. So a Collider 2D, any type will work. So I'll just keep it generic like that. And we can just call it Collider 2D col. So on awake, we want to find that. So void awake, and we do col equals get component Collider 2D. So what I want to do is to maintain a list of the objects that are inside of the detection zone. So let's create and we'll make it a publicly visible list as well. So a public list of Collider 2D, and I'll call this detected colliders. And at the start of our script, this will be equal to a new list of Collider 2Ds. So we can get rid of start and update. We don't need that. Instead, what we're going to be responding to is void on trigger enter 2D and private void on trigger exit 2D. So when something enters the zone, we want to keep track of it. So detected colliders dot add collision, and then when it leaves the zone, detected colliders dot remove collision. So this should keep track of everything that is inside of the zone and was able to collide with this object, the detection zone object, on the collision layer. So back in the Unity editor, we can expand the detected colliders list. See that this is empty by default. So we should not manually add anything to it. Let's go ahead and hit play. And well, we're looking at the prefab, so it won't show anything. Let's exit the prefab, expand the night enemy, click on the detection zone, hit play, and you'll see that the player actually showed up there for a second. So when the player is in the zone, we can use that information to trigger the attack state inside of our night script. So I'm going to go to night enemy. Up at the top, I'm going to declare a public detection zone, and I could just call this attack zone. And we're going to set this reference directly. And we made it public so that we can set it in the inspector. And what we're going to want to do with this attack zone is check on each update whether there is something inside of the list or not. So down here, we can actually put this on the update function. So I'll get rid of start, and let's move update right up above here, above fixed update. Because this isn't a physics function, we can just let this run as many times as our system is capable of updating, rather than a fixed number of times per second. So we can update a property that will also update the animator component, and I will call this has target equals, and we'll do attack zone dot detected colliders dot count is greater than 0. And we'll just update that on every frame. So let's create the property now. Control period on has target, generate the property. So we have it up here. We'll need a custom setter, so I'm going to need to create a field for it as well. Public bool underscore has target, and that'll be false by default. At the start of the game, we shouldn't generally have a target, and we want to wait till we have it manually set up. So for the get, we'll do return has target, and then for the set, we will do as target equals value. And then we're also going to want to set the same value on the animator, which means we need to get reference to the animator component. So up here at the top, animator, and just like before, we're just going to get this on awake. So animator equals get component animator on awake. Super simple. So now we can do animator dot set boolean, and we'll do animation strings dot has target. And now we need the value, which is value, of course. So let's just even out these lines a little bit nicer. And now that this boolean is set, we should be able to switch between attack states and movement states like run. Of course, let's also take detection zone and put that in the scripts folder and hit OK. Okay, so now back out on our night enemy. Let's take a look. We have the detection zone, and we should be able to set our has target function. So let's hit play and see if we get the attack to trigger. So we get a null reference exception. So that's because the night enemy does not have the detection zone specified. So I'm going to open up the night enemy. We'll come down to the night script. You can see attack zone is not set. So we need a detection zone. So I'm going to drag the child game object detection zone into that field, and we'll grab the component immediately, and we'll use that for has target. So let's hit play. And now we can see that when the player is in front of the knight will swing at us. So let's move the knight further back in our scene. Also decrease its speed for a second. Let's make the walk speed 1 so that we can kind of get it to trigger a bunch of times. So we have the animation there. Our knight's still walking, and the knight is still able to move while walking. We might be okay with that for the knight. But we do have a problem, which is that if the player walks into a knight swinging the sword that fast, he's definitely going to get hit. So we need to slow down the knight's attack animation in one way or another. So a quick way to do it might be to grab the attack animation state and then change the speed of it to something like 0.5. Now hit play, and you'll see that the sword goes much slower now. We might even want to slow it down to something like 0.33. Walk into it, and you can see that the sword is swinging much slower. So I'm going to put it at 0.5, but what I actually want to do is take the first couple frames of the knight's attack and space them out more, so that the charge up of the attack is slower than the final part of the attack. So let's go to animation. With knight selected, go to attack. We can zoom out on the animation sheet, and let's take the first 2 frames and make them 2 frames long. So we have one at 0, and 0, but then the last 2 frames, the sword hit frames, only last 1 frame each. So if we hit play, you'll see that the charge up is now really slow compared to the final bit of the sword attack. So if we hit play, then we'll have quite a bit of time to respond to the knight swinging at sword. So after testing this a few times, I don't think I like the knight being able to slide across the screen while it's attacking. I mean, the player can't, so is it fair for the knight to be able to do that? So what we'll do is let's also add in a CanMove variable for the knight itself. So when the knight is inside of an attack state, then it won't be able to move. So let's go back out, click on attack, double click into it. And then in the inspector, let's add a behavior. So we have the set boolean behavior. So add that in. For the boolean name, CanMove. And we'll update this on state machine. So the value on enter is going to be false, and the value on exit is going to be true. So that means that while the knight is attacking, it can't move. So now we just need to add the boolean here to the list of parameters. So CanMove. So this CanMove should actually be true by default, since at the start the knight is going to be moving. In advance though, let's go back to the base layer and add a similar boolean behavior to hit and death so that the knight can't move while it's being hit. So set bool behavior, CanMove, but this time it's update on state because it's just this one single state. It's not a sub-state machine. Value on enter is false and value on exit is true. Then add the behavior for knight death, CanMove, update on state, value on enter false, and value on exit true. And that should be enough to have the CanMove variable properly updated depending on the states. So let's add another property inside of Visual Studio for the knight. So this is just going to be CanMove. So we can add it right below has target. So public bool CanMove. And this is just going to be a getter function. So get, and we're going to return animator.getBool. And the parameter we're looking for is animation strings dot CanMove. And that's going to be a true false. And so when we get CanMove inside of this script, we're just getting the parameter off of the animator. So we can take this down below to the fixed update, and if we're going to try to move the player, we want to check if CanMove is allowed. So if CanMove, then we will set the rigid body velocity. Otherwise, we can set the velocity of the x direction to 0. So equals a new vector 2, and this is going to be 0 rb velocity.y. So now when we hit play, we can walk to the enemy and see that when the enemy is attacking, it stops moving entirely. Now, that might look kind of clunky, where it just stops instantly. So what we can do is we can actually have it slow down to 0, but over the course of a few frames. So instead of putting 0 for the RB velocity, we can instead do mathf.lerp, and we're going to take the RB velocity x, the current value, and we're going to move it towards 0 at a speed. So we'll call this the walk stop rate, let's call that. So each time it goes through here, it's going to move it towards 0 at a certain percentage between 0 and 1 being 100%, on each call for this. So I guess that would be per each fixed frame. So I'm going to copy this variable. We'll go up to the top. Let's create a public float for that. Public float walk stop rate. And I'll default this as something like 0.6. So it'll stop pretty fast, and of course we can customize this and mess around with it a little bit. But now it won't stop to 0 instantly, but it will take a couple frames for it to actually go to here. So let's hit play now and test that. So it does seem to stop very, very fast still. So we can test with different numbers. So on the night script, let's take the walk stop rate, and I'm going to try 0.2, and then let's hit play. Still rather fast. Let's try 0.02. So back in Unity, let's go ahead and hit play and see that basically the enemy is still stopping almost immediately. So let's go to night enemy. So the walk stop rate, I'm going to try 0.05, something much, much slower. Let's try increasing the night speed to 10. So now when we hit play, we can actually see that the knight does have to slide a bit before it can swing the sword. So that's kind of more what we're looking for. So the numbers we want to put on the script might be something a little bit more like 0.05 or 0.02 for the walk stop rate if you want to see a little bit of that slide while the knight is making a sword attack. And the walk speed, of course, we had that originally at 3. So inside of the knight script, I think I'll make the walk stop rate 0.05 and 3 for the walk speed as the base values. So going back to the default script values of walk speed 3, 0.05 walk stop rate, let's hit play. Okay, and we can see there's a little bit of that slide going on. That's probably a lot closer to what we want. So we have the walking. Our knight will take a swing at the player while it's within the zone and continue onwards after it has left the zone.